In the second part of Section 8, we're going to talk about something called dimensional analysis. So by the end of this lesson, you should be able to convert rates using dimensional analysis. So to change one unit of measure to another, you can use rates that equal 1. Since 60 minutes and 1 hour are exactly the same amount of time, we can write them as a ratio or as a fraction, and this fraction is really just a big giant number 1. 60 minutes divided by 1 hour is 1. We can also flip this around, and 1 hour divided by 60 minutes is also just a big giant 1. And we're going to be using stuff like this as a conversion factor to change hours into minutes and minutes into hours. So I'm going to give you a problem on the next page where we want to cross units off. So in order to do that, we'll have to think about how we want to use this conversion factor. When converting from one unit to another, as in hours to minutes or minutes to hours, you have to decide which one to use. And this is called unit analysis, or I'm going to call it dimensional analysis. When you get to chemistry, this is called stoichiometry, and it's exactly the same thing. So here's your plan of attack. Write down what you know, whether it's a measurement or a ratio. Leave lots of space. Write an equal sign, a smaller space, and then the units of what you want to know. So what you want your answer to be. You're going to fill in the middle with your conversion factors to cancel the units that we don't want. And most likely, you'll have to pull outside information. Sometimes that outside information is stuff you already know, like you know that there's 24 hours in a day, and then other times you'll have to look stuff up. Check it before you do the math. Do the math. Make sure your answer is reasonable. If I'm asking you to convert the number of hours in a day to seconds, you don't want billions and billions of seconds. That doesn't make sense. Circle your final answer and make sure it has units. The whole point of this is that it's unit-based, so I want to see your units. So let's convert 24 hours to seconds. So the first thing I have to do is write down what I know. So I have 24 hours. Then step 2 says leave lots of space for work. And how we're going to show our work is we're going to turn this into a giant fraction. Next, write an equal sign, a smaller space, and then the units of what you want to know. So somewhere along here we're going to have our equal sign. And let's say it's right here. And the units we want are seconds. Fill in the middle with conversion factors. So, what do you know about hours? Chances are you know that 1 hour is exactly the same thing as 60 minutes. Now, that's not what we want, but it's getting us closer. So when we look at this, remember we can convert this into a fraction. We could put 1 hour divided by 60 minutes like this. And we're really multiplying by a big giant number 1 because those are exactly the same thing. But if we do it this way, we end up with the units hours times hours divided by minutes. And what we want is for hours to go away. So I'm going to put hours on the bottom. 1 hour is the exact same thing as 60 minutes. And now we need another conversion factor. If we were to stop this problem right now, our hours would cross off since we have 1 on the top and none on the bottom, and we would be left with the number of minutes in 24 hours. But we want seconds. So our other conversion factor we're going to use is that 60 minutes is the same thing as 1 second. Let's try that again. 1 minute is the same thing as 60 seconds. And then we have to stop and think how we want to write this. Remember, we want these minutes here to cross off, so I'm going to put minutes on the bottom and 60 seconds on the top. And now our units of minutes cross off, and we're left with units of seconds, which is what we want. So we know that we're done with this part, this fill in the middle with conversion factors. So check it before we do the math, and then do the math. So the thing that you're checking is that everything crosses off that you want it to, and that you're left with the units that you want. So now the math says multiply the top, multiply the bottom, and then simplify. So on the top, we end up with 24 times 60 times 60. We get 86400 seconds. And on the bottom, we just have a 1. And since this is a nice, easy problem, we end up with the fact that there are 86,400 seconds in 24 hours. So let's try another one. Let's convert 250 miles into centimeters. So we start with what we know, 250 miles. Make this big, leave lots of space. And we eventually want to get to centimeters. So some outside information that we need to know is that 1 mile is the same thing as 1.61 kilometers. So we're going to use this as our next conversion factor. And remember, we want miles to go away. We eventually want centimeters. So I'm going to put the 1 mile down at the bottom, and that's 1.61 kilometers. So if I was to stop the problem right now, my units would be in kilometers, but I want centimeters. So if you think back to last year, you might remember that 1,000 meters is the same thing as 1 kilometer. So I'm going to use that as a conversion factor. Remember, I want kilometers on the bottom because I want it to cross off. And if I was to stop my problem right here, I would have my units in meters, but I want centimeters. So we got to keep thinking. From last year in science class, hopefully you remember that 100 centimeters is the same thing as 1 meter. So we have 1 meter down at the bottom, because remember we want it to cross off. It's the same thing as 100 centimeters. So now we're finally at the units that we want. We want centimeters, and we have centimeters. So all I gotta do is multiply the stuff together. And just like the last one, we're gonna divide this one by 1 since everything's 1 on the bottom. So it's 250 times 1.61 times 1,000 times 100. And we should end up with a huge answer. Think about how far 250 miles is. That's like from here to Chicago. And if I wanted to measure this in centimeters, it's gonna be enormous. And we end up with 40,250,000 centimeters. So if you notice, both of these that we did are measurements, and we had to convert those measurements into new measurements. The other thing you have to do with dimensional analysis is convert ratios. So let's try another one. Let's say I have 55 miles per hour, and I want to change it to feet per second. So remember, 55 miles per hour means 55 miles in 1 hour. So now I basically have 2 sets of units that I have to change. I have to change miles into feet and hours into seconds. Doesn't matter which one you do first, but remember we're going to end up with something in feet per second. So let's take a look at hours, because that's going to be the easiest. So the information that you know is 1 hour is the same thing as 60 minutes. So we want the hours to cross off. So I'm going to put that up at the top. And if we were to stop right now, we would have miles per minute, which we're getting closer, but we're not where we need to be. So let's keep going. Let's keep changing this. We got to convert it to seconds. So we know 1 minute is the same thing as 60 seconds. So remember, we want minutes to cross off, so that's going to go on the top. Seconds goes on the bottom. And if we were to stop right now, our units would be miles per second, which is close. We have the seconds part, but we got to convert feet into miles. So our next conversion factor, we might have to look this up, but I'm going to tell you right now that 1 mile is 5,280 feet. So if we want miles to cross off, that's going to go on the bottom. And 5,280 feet are going to go at the top. So if we stop now, miles and miles cross off, we have our units of feet per second. We have what we want. So that means we don't need any more conversion factors. Instead, what we have to do is multiply everybody on the top, multiply everybody on the bottom, and then divide. So 55 times 1 times 1 times 5,280 gives us 290,400 feet, because those are our units. And then 60 times 60 is 3,600 seconds. And then we can divide those. And we end up with 80.7. So 55 miles an hour is the exact same thing as about 81 feet per second. Let's try another one together. $4.15 per pound to pennies per ounce. So we start with what we know. $4.15 per pound means we have 1 pound. And we eventually want to end up with pennies per ounce. So we got two things to convert again. Dollars to pennies and pounds to ounces. So everyone should know that $1 is the same thing as 100 pennies. So let's do that one first. So $1 is going to go on the bottom. Is the same thing as 100 pennies. Because remember, we want our dollars to cross off. And if we were to stop right now, we'd have pennies per pound. So some outside information that you may not know is 1 pound is the same thing as 16 ounces. So if we want pounds to cross off, we got to put that up at the top. So now our pounds cross off. And we are left with pennies per ounce. That's what we want. So all we got to do is multiply what's on the top. 415 times 100 is 415 pennies. And then on the bottom we have 1 times 1 times 16. So if we divide, we end up with 25.9. So $4.15 per pound is the same as 25.9 pennies per ounce. So I'm leaving you one to do, and this one is quite difficult, but I want you to give it a try. Your question asks you, if there are 5 Firminus Bandersnatches, how many Jabberwocks should there be? Here are your conversion factors. So like these things that I was giving you here, now they're here. You start with the information that there's 5 Firminus Bandersnatches, and you need to end up with Jabberwocks. Use your conversion factors to cross things off and figure out how many Jabberwocks there should be. Make sure you at least give this a try, because I will definitely check it tomorrow. If you have any questions on the notes, make sure you write them down and we can answer them in class. Enjoy your night.